Welcome to this new module where we now want to talk about the different storage services. In my opinion, this is a super exciting module because in practice this is super relevant. And also it allows for a lot of practical demonstrations. And that's why we want to make this as practical as possible so that you can also apply this knowledge practically. We want to lay here a strong foundation for the understanding of the storage services. We want to start this module with talking about the storage account. That's some kind of main account that we can use to have access to other services. But we will also talk about additional things that we will discuss in this entire module. So it's some kind of an overview. Therefore, let's get started now with talking about the storage account. The storage account is, as I've mentioned, like an account that offers additional storage services. So we can create one or several storage accounts, and this acts like a high-level account in which we have access to different types of other storage services. For example, we have a Blob Storage. That stands for Binary Large Object. In Azure, this service is also called containers. We can create multiple containers. They act like folders. And blobs, so the data that we can store in them, ranges from video files, pictures, text files. We have a very broad range of files. Oftentimes it is very large files because this type of storage is relatively inexpensive, and therefore this can be a basic but very efficient method to store data. Then we have also file shares and queues. Queues are, for example, something like messages that can also be used from other services. And then also the last service are tables. This is a NoSQL database, so a non-relational database, and we'll also talk about this. These are the four main services. Of course, there are more services than just these four services. For example, there are also SQL databases as a service. And we'll also talk about them, but they are not part of the storage account. But still, this storage account is kind of the most important service because these services that we can use under the storage account are very, very foundational, and therefore this is kind of the most important data storage service. Therefore, in this lecture, we'll talk about these different services within the storage account, but we also talk about additional things that are important if we talk about these storage services. We also talk about the access tiers. There are three different types of access tiers, and this affects the pricing of this storage. For example, if we don't really need to have oftentimes access to these files, we could use the cool access tier and save some cost with it. We'll talk about this also, as well as talking about the redundancy options. Also a very important topic. Depending on how important these files are, so how our requirements are on these files, how durable and lasting these files need to be, we can choose between different redundancy options. A super important topic. We'll also talk about additional services and things that are relevant, like disk storage, which is necessary for virtual machines, file sync, if we need to have some files synced, for example, on virtual machines between different users. We'll also talk about data transfers, what are the costs related to that, and then some of the services that are also related to data migration. And lastly, as mentioned, we'll also talk about SQL databases. This is also something that's practically very relevant, and in general, we want to make this as practical as possible while also covering, of course, all of the exam requirements, but still this allows for more demonstrations, and therefore we want to make this a little bit more hands-on as well. And we want to start now in the next lecture by creating our own storage account within the Azure portal. Let's now create our first storage account. We can, of course, again just search for storage accounts, and there you find also storage accounts. I already have created some of these accounts before, but we can also just see how we can create a new one. Therefore, we want to now select create, and again we can start with the basic. These are the most important configurations. In our case, let's create a new resource group again. We will call this storage account resource group. We say OK, and this will be where we will store this storage account. Afterwards, we need to provide a storage account name. And now this is important, that this needs to be unique across all existing storage accounts in the entire Azure cloud. So this needs to be important because then we can access this by using this unique storage account name. Therefore, in my case, I'm just trying, for example, if I try storage account, I will see this is probably not unique, and therefore I have to add some additional maybe letters or numbers. In my case, I will, for example, enter some additional letters like test, and then maybe some numbers, for example, in my case, these numbers, and now this is possible. This will be the name of our storage account. Afterwards, we can select a region. Of course, again, usually we want to deploy this as close as possible to our application or to the users where this is accessed from. I will, in our case, just leave it at East US. Then we have some option for the performance. We can leave this in general at standard because this is the best solution for most scenarios. In this option, we have access to all 4 services. If we need some very special requirement with extremely low latency, we can also use the premium performance. In this case, we have to choose an account type. And in this case, you see, we have only access to these different types. We cannot use tables, we cannot use queues, and we are limited to just these 3 options. In our case, therefore, we can just leave it at the standard option. And then we have the redundancy. Again, this is very, very important, and therefore we will also talk about this in the next lecture. We will have a little bit more time to dissect this exactly. But just for short, we've already heard about this. These are the replication methods. For example, in our case, we can just use the locally redundant storage. In this case, it will be just replicated 3 times within the data center. So this is the lowest cost option, and in our case, this is absolutely fine because we are not storing any super sensitive data there. Afterwards, we can go to the next options. For example, in advanced, we don't need to make any adjustments. We have networking, the network access, we can leave it at the default option, so it's publicly available from all of the networks. In our case, this is absolutely fine. We want to access this just through the internet, and therefore this is okay in our situation. Afterwards, in data protection, we also don't need to make any adjustments. We could configure like how many days after a file has been deleted it can be still recovered, and some more options that are in our case not important. We can leave it just at the default. And the same is also true for encryption. Here we could change the encryption, but in our case, it's absolutely fine to leave everything at the default. Then we can go to review, and after a quick validation, this is fine, and we can now go ahead and create our first storage account. After a few seconds, the deployment is completed, and let's go therefore directly to this storage account. We can see in the overview just some of the basic options like the resource group where this is stored, again the location, subscription, and also the performance, replication method, which we'll talk about in the next lecture, and then we have access under data storage to our different services. We have the containers that we'll also of course talk about, and then also all of the other data storage services. And again, under overview, we have this replication method, a super important topic, and that's why we want to just again have a closer look again at this replication method in the next lecture. If we want to store data in our storage account, of course, we need to think about the redundancy options, because we want that our data is highly available and also very durable. This means after a period of time, all the data is still there and we don't lose the data due to some kind of failure. And therefore, it is very important to understand the different redundancy options in our Azure account. And they protect against planned events, like for example, some kind of updates, and also unplanned events, like some kind of disasters or failures. If we create our account, we see that in the account, we can select the redundancy. We have different options available there, and it is very important to understand these redundancy options. In general, we can say that there are always multiple copies, at least 3 copies, but the way those copies are created and the way the data is replicated is different in these options. In general, it's always a trade-off between high availability and high durability versus a high cost, of course. We want to have, therefore, the right option when we choose these redundancy options. Therefore, now let's have a closer look at these options. The first one, this is the lowest price and of course also the least durable, the least available. This is just a locally redundant storage. In this case, we just have 3 copies within a single data center. That's the lowest cost, least durable, and it just protects against some kind of failure in our data center. For example, a hard drive crashes or some kind of server rack has also a failure. It cannot protect against a disaster in our data center. So for example, there's some kind of fire, a flood, or something that is affecting the entire data center. In this case, the data may be lost forever. And if we want to protect against such an disaster in the data center, we need to use zone redundant storage. This is now replicating the data 3 times across 3 availability zones in a given region. Therefore, we have a separate physical location and we just protect against such a disaster in a data center. But this is still not protecting against a regional disaster. Maybe there's some kind of regional disastrous event, and then in this case, we have an even higher redundancy option. This is now a geo-redundant replication. This, in the first step, creates just 3 copies in 1 region. This is a locally redundant storage. So we have first within 1 data center in our primary region. This is the region we select in our storage account. But then after those copies have happened, there is a second 3 copies in a secondary region. This is also called asynchronous replication because first the 3 copies are created and then afterwards, after this has been committed, we have also these 3 copies in the second region. You don't need to remember the name, but we have to just understand in general how this works and what this protects against. In this case, the secondary region will just be the region pair of the primary region as it is defined by Microsoft. Regarding the geo-redundant storage, per default, we don't have read access to the secondary region. This only is possible after some kind of failure, but we have the option to enable this read access also even without the failure. This is what we get when we check this checkbox in the redundancy option. Then we also have read access, which can also improve the availability. So this will not only be then for recovery purposes, but also to increase the general high availability. And this geo-redundant storage in general now also protects from a regional disaster. If we now want to take this even 1 step further, this is now the replication method with the highest durability, the highest availability and consistency. In this case, we can use geo-zone redundant storage. This is now, as the name suggests, a combination of geo-redundant and zone redundant. This means we have 3 replications across 3 availability zones. So this is a zone redundant storage, but then we have also 3 additional copies in the secondary region using zone redundancy, again replicating across 3 availability zones. And with that, we now have the maximum durability, availability, and consistency. These are the redundancy options that we have available in our storage account. Let's talk about the first type of service in our storage account. That's the most important one, and it's the Blob Storage. Blob just stands for Binary Large Object. And this is the solution in our storage account to store massive amounts of unstructured data. That's very cost optimized, and therefore the solution to store any type of file like images, documents, backups, videos, and other files that we just want to store in an unstructured way. That means we don't have like a very organized table in a database, but we just put the files in so-called containers. A container is like a folder, and we use that to organize our files. So we can create multiple containers and put different files in these containers. We can see this is also the name, the service in our storage account. But we have to remember that a container is not hierarchical. This means we have our storage account, we can create one or multiple containers, and then we put the files inside these containers. But now, inside a container, we cannot create additional containers. We can, of course, create additional containers, but it's always at the top level. So we always create a container, and then we can put as many files in there as we want. This is the Blob Storage. And now, of course, let's now head into our Azure account and create our first containers and upload the files in our containers. Let's now have a look and see how we can create and manage our containers. To do this, we need to navigate into our storage account. In our case, we can see that directly here in our favorites, either on the left side or also here, but of course we could also just search for the service. I'm going now to the storage accounts, and we have of course created this account before, therefore I am selecting this one. We can also collapse them so we have a little bit a wider view. And in here we find now under data storage our containers. And if we go there, we can see that in here we have the option to create a container. We do this by just clicking on plus container, and then all we have to do is add a name. In our case, this could be test container. And be aware, of course, here will be again a check if the name is working. For example, I am able to use this name, but I would not be able to, for example, add some special characters or even some uppercase letters. This is all not allowed, and therefore I'm just going with this simple name. The public access level is now determining if we are able to access this. We can change that also later on. For now we can leave it at private, and then we will also see why we sometimes of course want to change that. And then we can just go ahead and create our first container. This container is created very quickly. We can open that, and now we can see that there is now the option to upload some files. Let's do that by clicking on upload, and in here we can now select a file. I can just navigate to the folder where I want to upload something. In this case, it's just a simple logo. And this can be then uploaded directly. And we see it is now available in our container. Now we could select it. We can see that this file is there. In here we could have access to this URL. And we can also have a look if we go, for example, to edit. We can even see a preview. And in our case, let's try now to access this image by using this URL. So if we would want to do this, we can just paste that in a new browser tab, and it seems this resource does not exist. We don't have access to it. And this is now because of this access. We can change that access level for the entire container just by going to change access level. This is now the same that we have seen when we created this container. In here we can now change it from private to container. And in this case, if we do this, all container and blob data can be now read by anyone. So this is sometimes, of course, not so safe. That's not what we want. But in our case, this is completely fine. We are changing this access level. And now again, we can refresh the page. And now we are able to view this file. We can download it. This is now all possible. And if we want to delete this container again, we can go back to our container. And in here, we can select it and we can delete this container. We want to confirm that we want to delete this container. This is fine. And then this has been deleted. These are the containers in our storage account. The more data we are storing, the more important it is also to control and manage the cost of our data storage. And we can also do this by choosing the accurate and most suitable access tiers in our situation. If we have a look at the website where we can find the pricing about the blob storages, we can see that the pricing, of course, depends on the volume of data. And also, of course, how many operations we are performing. And then if we scroll down, of course, also on the redundancy option that we are setting, as well as the region that we want to store this data in. But now if we scroll down, we can see that the data storage prices also depend on these so-called access tiers. So depending on how frequently we access and modify this data, it is more suitable to choose one or the other access tiers. And therefore we can already see that the data storage for the hot tier is more expensive than for the cool tier and even more expensive than for the archive tier. And also we have the premium, which we have already seen when we created our storage account. This is a little bit of a special case because in here we just have a extremely low latency. And therefore we will mainly consider hot, cool and archive access tier. But now the data storage, as we've seen, is more expensive in hot. But if we scroll down, we can now see that the operations, for example, write operations, are now much cheaper in the hot tier than, for example, in the cool tier. For the archive, the write operations have the same price than cool tier, but now if we have a look at the read operations, so now we want to retrieve the data, we can see archive is now extremely expensive. And now if we have a look at the hot tier, this is now much cheaper. And this means if we have data that is accessed very frequently, very actively, maybe it is also modified a lot, then it can be much cheaper and it's a better idea to use the hot access tier. And that's why we now want to learn a little bit more about these different access tiers and what are the situations in which we want to choose which access tier. We have seen that we have these three different types. We've already seen hot, cool, and there's also archive. We've mentioned that hot is the most expensive in terms of the storage. But now it is much cheaper to read and write the data. This is also having a very low latency, very high availability, and therefore it is in general good and most cost effective for frequently accessed data. Examples can be that we have a document that needs to be accessed very frequently, or some images on a website that has thousands of accesses per day. In this case, the hot access tier would be the best one. Then we have also the cool tier. This is now already a little bit cheaper than hot in terms of pure data storage. But now the operations are already in general more expensive than the hot tier. And also the latency, it's kind of almost the same as hot, and also we have a little bit of a lower availability, but they are about the same. And now this cool is just more cost effective for data that is not so frequently accessed, but it's still kind of active. Maybe some invoices that we need to see maybe on a monthly basis. Maybe we even have some kind of short-term backups that we know at some point we probably have to access this again. Or maybe also some larger data sets that are just more cost effective to store them in the cool tier because we are not accessing this so frequently. But now, lastly, we also have the archive. This is now much cheaper than the other two tiers in terms of data storage. But to access this data is now really not only much more expensive, but it's also much more complicated because we cannot just access this immediately. We have to first rehydrate this tier. This is an offline tier and we cannot directly access it. So this takes a few hours up to even a day before this can be accessed again. And therefore this is suitable only for long-term backups or some kind of data archiving. Maybe there are some regulations that data needs to be archived and kept for a long period. In this case, we can use this archive offline tier. In general, we have a default setting for the new blobs that are created that is set in the storage account level. And here we can set either hot or cool. So one of those two. Archive is not possible to set as a default in the storage account level. The default is, if we don't change anything, it will be set to hot, but we can change it also to cool, so that whenever we create a new blob, the default for this blob will be cool. And we can, for every single blob, we can change this access tier. This is also possible. And now, of course, let's have a closer look at this in practice and head over into the Azure portal. Let's now have a look at the access tiers in our storage account for our blob storages. We can set the default at the account level. We can only set it to the hot or cool, and that's what we want to have a look at in the first step. So therefore, let's again open up our accounts. We can just go to create a new account, and there, if we go to advanced, we see that there are some options, and if we scroll down, we have also the access tier. And in here we can see it is either hot or cool. Hot for frequently accessed data, day-to-day usage, and then also cool for infrequently accessed data and short-term backup scenarios. This is the default. And now if we have a look at one existing account, what happens if we upload some new data in our containers? What will be the access tiers and how can we change them? For this, let's head over into our existing storage account. I have created this one, so let's open it. And in here we can also again collapse it and go to our containers. I want to first create a new container, so we can call this access tier container. And now this will be created. Let's do this very quickly. We can open it, and in here we can now upload a file. That's what we've already seen. We can upload a new file. So for example, I'm again selecting the file that I've uploaded already before. And now under the advanced settings, we can scroll down. We can now see the access tier is set to the default. And this, as we've seen, is inferred from our storage account. So this is inherited. But of course, it is also possible to change it. So for example, for this one, we can change the access tier to cool. And now we could also change it to archive. Let's first set it to cool. And now let's immediately upload this file. This is now immediately uploaded. And now, of course, we can also change that access tier. To do this, let's open up the file again. So now we have already uploaded this, and now we want to change this access tier. Therefore, we select it, and in here we can now change the access tier. We could change that now, for example, to archive. And in here we already see the message setting access tier to archive will make your blob inaccessible until it's rehydrated. And then if we want to access it, it needs to be first rehydrated to hot or cool tier. And this may take several hours, and this also incurs more cost if we want to rehydrate this. This is what we can do. So we can now save it again, and this will even take already some time until it is in the access tier archive. And now if we would want to open that, we cannot access this file. So if we go to edit, we cannot even see a preview. This says this is currently archived and can't be downloaded. We first need to rehydrate this. This we could do by, again, just going to change the tier, and we could now move it to cool or hot. And then this will take a little bit of time, and also it will incur some costs. We could change it again to cool, and also there's a rehydrate priority. So if we set it to high, it will be a little bit more expensive, but it will rehydrate a little bit quicker. In our case, we don't need to do this now. We just want to demonstrate how this works. And in our case, we can now even go ahead and delete this entire container again. So therefore, we can go back to our containers, and we can select our access tier container, and we want to delete this. We can check the box and say this should be deleted. This was just a quick demonstration on the access tiers in practice. Hope it was helpful, and see you in the next lecture. In this lecture, we want to talk about queue storage, which is part of our storage account. The purpose of queue storage is to store large numbers of messages. And the idea of that is that we want to create with the queues some kind of backlog of work. These are messages that will be stored in a queue. This means that sometimes, for example, some application is producing a large number of messages, and they cannot be processed immediately because sometimes this takes more time to process them, and that's why we want to build up a queue, and then one by one, once the time is there, we want to process these messages from the queue. And then once they are processed, they should be dequeued one by one once they have been processed. One queue in our queue storage is a set of messages. This means that we can have multiple queues with multiple messages. And it's possible to access these queues with a simple HTTPS request. We have a URL for all of the queues, and like this, they can be accessed very easily. To see this in action, let's quickly have a look into our storage account. Let's open that up. And there we have also under data storage our queues, and we can see that we can create a new queue. We only have to give a name. This is, for example, test queue 1. We create it like this, and then we can create messages in this queue. We can already see this is the URL. It's a very simple URL with the name of our queue included, as well as the storage account. And then if we open up this queue, we can now create messages in these queues. We can create, for example, this is message 1. We can create it, and then we can also create a new one. For example, this is message 2, and then we can create another one, message 3, another one, message 4, and so on. And now that we have 4 different messages, they can also be dequeued. They will then be processed and dequeued one by one, starting with the first and oldest message. So in our case, message 1. This is the idea of queues, to store messages that are waiting as a backlog until they are processed. That was just a quick demonstration and a quick overview of the queue storage. Let's talk about another very foundational storage type, and these are Azure Files. The idea of Azure Files is that we have a fully managed file share in the cloud. What's the purpose of this? If we are working in a company, it's very likely that there are some files that need to be accessed by multiple people from multiple devices. Or of course, if we are working in the cloud, it is also possible from multiple virtual machines. And now the solution for this are Azure Files. We can create such file shares, and now the great thing is that this can be mounted either by some cloud virtual machine or some on-premise device. This means that we can access this like a local hard drive, and this makes it very convenient for all of the people to access these files just from their device or their virtual machine. And like this, we have some kind of replacement or at least some supplement on the on-premise file servers. If we were working in a data center, then the solution or the replacement of this would be this on-premise file server. And now we have also a cloud solution for this. These files can be accessed via SMB protocol or NFS protocol. And we can mount those file shares by any common operating system such as Mac OS, Linux or Windows, of course. This is the very basic idea of Azure Files, so that we can have multiple people accessing these file shares very conveniently from their local devices or their virtual machines. And now we want to have, of course, a closer look at this in practice in the Azure portal. Let's have a look at this now in the cloud, where we want to see how the Azure Files work. For this, of course, first we need to go to our storage account. There we can find under data storage also our file shares. If we open this up, we can first of all create a completely new file share. If we do this, we can give this a name. We have to follow again some naming convention. So for example, uppercase letters are not allowed. Therefore, we can say our first file share, for example, and we can also select a tier. We can have this being optimized automatically, or we can also choose either the hot or the cold access tier. In our case, we can just leave everything at the default, and now we can create our first file share. In just a few seconds even, this will be created, and now we can open up this file share. And now in here, we can either directly upload a file, or we can also say we want to add some directory. So for example, these are, let's say, our video files. And then we can say, okay, and now we have a directory for the video files. In here we can now add another directory, for example, the video files from 2023. And there we could go on and on, of course, and we could now upload also a file. So if we select it, we can again choose to upload some file. For example, I can choose again this image file, and we can upload this one, so it is now present in our file share in this directory. And we could now, if we go back to our file share, also say that we want to mount this. This means that we want to connect to this so we can access it from our local device or maybe also from the virtual machine that we are working on. To do this, we can just go to connect, and here we find the instructions for the operating systems Windows, Linux and Mac OS. We can choose a drive letter, an authentication method, and then if we, for example, use the storage account key, in this case we could just use this script. We can just follow the instructions and just paste in this script into, for example, PowerShell console, and like this we can mount this to our local device. This is how we can use file shares to make file shares that can be accessed from multiple devices very conveniently. If we are using Azure Files, it can make a lot of sense to also use file sync, especially when we are in a hybrid cloud constellation. This means we are using both Azure Files as well as some on-premise file servers. In this case, we can use file sync to sync the data from the on-premise file servers to Azure Files. And like this, we can use them both together. We have on the one side our on-premise file server. Usually this is some Windows file server. And then of course in the cloud, we also have Azure Files where we can create our file shares. And now if we have this constellation that we want to use them both together, it makes a lot of sense to sync the data between them. And for this, we use file sync to sync the data between on-premise and our Azure Files. Why would we want to do this? Why would we want to sync the data? There can be multiple use cases for this. One could be that we have multiple offices and there are multiple Windows file servers, and we want to sync the data now across these different offices and these physical locations. We can do this by syncing the data to Azure Files and then back to all of the offices. So like this, we can keep the data continuous across multiple locations, and it will be completely synced by using the cloud. Another option could be that we want to maybe reduce the amount of data that is needed for backup. So we use this file sync in the cloud as some kind of data backup for our on-premise file servers. So for disaster recovery, we can go back to the cloud if some of our devices on-premise are crashing. And we can even control how much data is used in the cloud by using some capacity for some cached data. Like this, first, the most frequently accessed data will be cached, and like this, we can control how much storage can be used to back up our most frequently accessed files, for example. And how this works is also very simple. First, we need to install the file sync agent on our on-premise Windows file server. And then we also want to add it to the Azure File Sync deployment in the cloud. And like this, we can define that the data between the two should be now synced. That's the idea of using file sync to sync data from on-premise file servers to Azure Files. Let's talk about the last storage type in our storage account, which are the Azure Tables. Azure Tables offer a NoSQL database solution. This means that we are not having relationships between the tables in our database. So it's a non-relational SQL database. The benefit of this is that this solution, especially the Azure Tables NoSQL solution, is very inexpensive. So we can store a large amount of very basic structured data if we don't need to have access to the relational features. So we don't want to be able to, for example, make complex joins between our tables. The Azure Tables are just a key attribute data storage without a schema. This means we have a very basic table structure. We cannot make any joins. In general, this is designed for high volumes of structured data. And since we use the Azure Tables from our storage account, we have all of the options also available there. So we have all of the redundancy options and the high availability. Let's see now how these tables work. We can, under our storage account, create multiple tables. And these tables contain multiple rows. In the Azure Tables, these are called entities. And one entity can have multiple so-called attributes. An attribute is just a combination of a key and a value. This is now complicated speak, for we have a table with columns and rows. And one value in a column in a given row, for example, Frank as a first name, is one attribute. But now, what are the use cases of these Azure Tables? In general, we can use them to store large amounts of structured data, because this is very inexpensive. And if we don't need to make joins that are very complex, then we can use Azure Tables to have an inexpensive database service to store structured data. In the Azure cloud, we also have one other NoSQL database solution, which is Cosmos DB. Cosmos DB is more of a premium solution, so it is a little bit less basic with a better performance in some cases, but it's also more expensive. So therefore, Azure Tables is more basic, but it's also more inexpensive. So if we want to have a very cost-efficient solution to store large amounts of structured data, we can use Azure Tables for this. Let's have a look now at the Azure Tables in action. If we go to our storage account, again, we can go to the one that we've created before. And in here we find now under data storage also our tables. What we can do here is first of all create new tables. In our account, we could, for example, create a table that is called table 1. And then the name check will happen. This is something that we can use. Let's create the table like this. And we see here is a publicly available URL that is used to access this table. So that could be used then also to connect it to other applications. In this case, we cannot manage the table from here. This is not possible. We can use the storage browser for this. If we go here, we can see also our blob containers, our file shares, and like this, we have just some more manageable interface that we can use to manage all of these storage types. In our case, we want to go, of course, to the tables. And in here, we can now click on it indeed, and now we could manage this table. For example, we could add an entity. This means we remember a row in our table. If we do this, we have to enter both of these keys. We have a so-called partition key and a row key. These help to identify each unique entity, so each unique row, and the table is also partitioned by them. These two columns, if you will, are indexed. And like this, we can use that more easily to filter our data. For example, we could say this should be the departments. We can say, for example, finance. And in here, we could use the row key, for example, the employee ID. And like this later on, if we want to filter a lot by the department, this has then a much better performance because now we don't require a full table scan because this is already indexed. And this means in simple speak that if we design our table with some properties that we want to filter very often, for example, the departments, we have a better performance when we want to filter the data with these properties. Therefore, I'm just going to use now finance and one, and now we could add additional properties. For example, I could say now we want to have also the first name. And in here I could, for example, now enter my name, and I could add another property, for example, last name. And in here I could again now add my last name. If I now insert this as a row, this will be inserted in our table and it is visible in here. Now we could, of course, add another entity. And now the interesting thing is, for example, let's again use finance. In this case, we have ID number 2. And now we could add another person. For example, again, Frank, and then in this case, Miller as a last name. And now the interesting thing is that we can now add additional properties regardless of the properties that we had in the previous entities. So for example, I could just add a column that is called, for example, age. In this case, I could add the age, for example, 27, and this could be still added to our table. And now we see that our table has another property of age. This is now very nice because now this makes it very flexible for us. And now we could query the data by adding filters. So for example, we could use the column partition key, and this should be now, for example, equal to finance. And now if we use in this filter our partition key, this has a much better performance than if we would use another field. which would still be possible, but just with a lower performance. And therefore, when we design these tables and the partition key, we should keep this in mind as well. So now I could apply and I get the result like this. I could now add another filter. For example, now I want to use the row key and I say this should be equal to 2. I can apply and get the result back. This is how we can use Azure Tables, mainly by using the storage browser. Now that we've talked about the different storage types in our storage account, we need to understand that this storage account is used also for other things. And this is, for example, that it's also used as a disk storage for our virtual machines. If we create a virtual machine, we remember that we, of course, also have some storage there. There are some disks that are needed for the operating system. So we have an operating system disk and we can have one or multiple data disks as well. And we also remember that when we stop a virtual machine, we can use that to save some cost, but until we delete this virtual machine, so if we only stop it, we still pay for the storage, because this storage is actually available and we of course need to pay for it. And these disks are actually stored as containers in our storage account. That's important to understand, that for the disks in our virtual machines, we use a Blob Storage in our storage account. Now, usually these disks are per default managed by Azure, so this means that they are not even visible in our storage account, because this is fully managed and completely invisible to us. But under the hood, Blob Storage is used for these disks in our virtual machines. We also have, in theory, the option to use unmanaged disks. This means that we are responsible to manage those disks. And then we will also actually have to choose a container manually ourselves, so some storage account where we want to store these disks. And this is something that is now not recommended anymore. And it's also not possible for all of the images, for all of the virtual machines that we want to use. So this is just still some option that is possible for some kind of images in our virtual machines. In general, we have different types of disks. They are serving different purposes and of course have different prices as well. For example, standard HDD is not meant for production. And of course, it also has the lowest price and the lowest performance. And then if we, for example, go to standard SSD, this can be used for some very light production environments. But then if we want to step things up and require some more performance, we can also go with the premium SSD. Let's have a look at this also quickly in the Azure portal. When we want to create a new virtual machine, let's just quickly provide some name, 1, 2, 3, and then the region and everything we can leave at the default. Then we can go to the next step of disks. In here, we can now choose an operating disk type. For example, I can say I want to use standard SSD. Afterwards, I can also create additional data disks. They could be now also just added to our virtual machines and they would be then there available. If we go to advanced, we could also uncheck this box of manage disks to manage this ourselves. This is, as I've mentioned, not recommended anymore by Azure, and also even it is not available for most of the images. Also, the availability zones requires managed disks. So it's now very limited to manage these disks by ourselves. But in general, even though they are invisible to us, they are stored as blobs or in containers in a storage account, even though it is not visible to us. So that's just helpful to understand with the virtual machines how the disks are actually stored under the hood. In the previous lectures we've seen how we can use also the storage browser to manage the different storage services. For example, if we go to storage browser, we can manage our tables. Something that we can also do if we go back to our storage account, so we basically just need to click on storage browser, is to use the so-called Azure Storage Explorer. This is very similar to the storage browser, but it's an application we can download and install locally on our machine, and like this we can manage our storage account from our local device, which might be just a little bit more convenient in some cases. So to do this, we can just click here on this link to download the Azure Storage Explorer, and then we will be navigated to this page, which we can also access directly. There we can of course select the operating system to download the installation file. After a few seconds, this installation file for the Storage Explorer has been downloaded and we can launch this installation file. Afterwards, we just have to accept the agreement and install this application. After a few seconds, this has been installed successfully and we can directly launch the Storage Explorer to see how this looks like. From within the Storage Explorer, we can sign in to our account and we can also just attach a resource. First of all, we want to sign in with our Azure account. In here, of course, we just use a normal Azure. We can click on Next. And afterwards, we are prompted to sign in to our account. And then we have authenticated to our account. So we can go back to the Storage Explorer. And now we are signed in to our account. Afterwards, we see on the left side now our subscription. Let's maximize this to see it a bit more clear. In here we can see that under the default directory, we can check this box, we have our storage account that we can now access from here. We can do this by just selecting Open Explorer, and there we find also our subscription from this account. We can have multiple subscriptions in one account. In my case, I have only this subscription, so I can expand it. And in here I see all of my storage accounts. For example, we can open up the account that we have just created before. And from here we see that there are our blob containers. We have already created them before. So I could select them also from here. And also I could now just manage everything from here. For example, I could now just upload something right from this application, or also download something just by using this application. And I don't even need to use the browser in the portal. I can just use this Azure Storage Explorer. This is just an alternative method if we don't want to use the Azure portal to manage our storage account by using this local application, the Storage Explorer. Let's talk about AZ copy. When we want to copy data from one storage account to another storage account, of course, one thing that we could do is to just download the data from one storage account and then upload it again to another storage account. This is not really a smart way, because not only we always pay for downloading, but it's also, of course, much more complicated, and it's not the way we should do it. We can use instead AZ copy. And what I want to talk about first is that when we download data, I mentioned we incur some cost. This is what we can see if we go to the bandwidth pricing. And here we see, if we scroll down, that, and this is now important, data transfer in. So if we bring data into the Azure cloud, it is always free. We don't pay to upload some data. So the data transfer to our account is completely free. But now if we want to get data out of Azure, or we want to move it from one account to another account, this incurs some bandwidth cost. So for example, if we move it just between different availability zones in the same region, it will not be super expensive. And also, of course, if we just transfer it within the same availability zone, it is also free. But now if we want to move it just between different regions, it will be a bit more expensive. And then also, depending on which region we want to move the data from and to, this can incur some cost. And also we have some egress cost. if we download data or want to get data out of Azure, we also have, of course, some cost. And alone for this reason, it really doesn't make any sense to first download data and then upload it again to another account. The better way to do this is to use AZ copy. Now, what is AZ copy? AZ copy is a command line tool that we can use to copy data between our storage accounts, or download also from the storage accounts, move files and blobs between different containers, between different subscriptions, between different regions. This is all possible. We can download this tool just to Windows and Linux and install it there and then use it locally on our machine. But we can also use it from within the Azure Cloud Shell. This means if we are in our account, we can access this Cloud Shell right from the portal. And we'll talk about this Cloud Shell later on, and then also we see how this works and what we want to use this for. And now we can use that, as I've mentioned, not only to download and upload, but we can also use it to sync and transfer files and blobs between different storage accounts. And again, it's possible to do it even across multiple subscriptions. This is all possible. As I've mentioned, it is a command line tool. This means we use commands to execute what we want to do. And the structure for these commands, and don't worry, you don't need to memorize anything of the command structures or all of the commands. This is just to give you an impression on how this works. In the beginning of this command, we have just always AZ copy. Afterwards, the command, what we want to do, for example, copy, and then the arguments that are necessary for this command. For example, we have AZ copy, then the command is copy. And now we can say which file, for example. We have an URL from our file, and we can generate even a URL with an SAS key. This is just one way of authenticating that we are allowed to copy this file. We have all of the right privileges and we can generate such a URL. For example, if we go to one of our containers, let's say we go here and we can close this one. For example, we have the container test that we've created before. If we click on these three dots, we can just generate an SAS token. And this means we can just set all of the different permissions. So for example, we have read permissions so that this file can be read. We can say this is between a specific start and expiry date, only maybe 1 day. And then we can say we want to generate this token and this URL. And then we can copy this URL and use it within our command. The same we can also do, of course, with different permissions. For example, the container we want to write to, we can give the add or write permissions and also generate such a URL with such a permission. So some of the commands are copy, to copy the data between a source and a destination, remove data, or even create new containers. This is all possible. You don't need to remember, of course, all of the commands. It is just important to know what we use AZ copy for. And this is that it is a command line tool to mainly copy. We can also download and upload data to and from our storage accounts. One of the big concerns companies have before they go to the cloud is the question, how complicated is the migration process? How complicated is it to replace all of our resources in our data center with resources in the Azure cloud? And obviously, Azure wants to make it as easy as possible for the companies to migrate all of their resources. And this is why they provide Azure Migrate. This is like a centralized hub that provides guidance and planning for migrations. So they want to make it with this platform as easy as possible for us to migrate from on-premise to the Azure cloud. And for this purpose, they provide a set of tools. And in the beginning, of course, the first step is to just discover what is actually available all in our on-premise data center. This, of course, is the very important step to discover all of the servers, all of the databases, their versions, what are the operating systems, what are our web applications, where is a lot of data, and of course, can this be replaced? This is why we first want to discover all of this. Afterwards, we can make a dependency analysis. This is done automatically also by Azure. We can use tools for that as well. And of course, in the end, there need to be also an assessment. What resources can be replaced? Are there maybe some problems? Maybe some versions are not replaceable in the cloud. Some servers are not available. And therefore, we need to know this, of course, before we start the migration process. Additionally, we have a lot more tools. For example, we have a cost analysis, how much the estimate cost is for the on-premise resources in our data center, and what would be maybe the expected cost in the cloud, which of course is also a very important information. So this is what Azure Migrate is. It basically is a platform where we have a set of tools that all help with the migration, with the goal to make it as easy and as plannable as possible for companies to migrate from on-premise into the cloud. And in this platform, we can create migration projects in which we can go through all of these steps and use also all of these tools. So just to give you a quick impression on how it looks like, we also want to now head over into Azure and have a look at this in the Azure portal. Let's have a look now at Azure Migrate, which is like a service that we can also access like any other service in the portal. For example, we can just search for Migrate, and there we find the service Azure Migrate. In here we have now a guided experience with a set of tools that we can use to discover, assess, and migrate all of our resources. In the beginning, of course, we start with discovering. And we can do this by just going to this discovery process. In here, the first step is always to create a migration project, because we of course want to also structure this into projects. In this case, we can just go ahead and create this project very easily. Of course, this also stores and collects some metadata, and this is why we also want to have this in a specific resource group. We can, in our case, just create a new resource group, for example, resource group migrate project X, for example, and then create this. Then, of course, also we can have a project name. So, for example, migrate project X. The geography we can choose, but this is only for the metadata that is collected. This is not related to where we discover our resources. We can discover them in any other geography or region as well. In our case, we can just leave it therefore at United States and create this migration project. After this has been created, we can just follow a very simple step-by-step process. We just start with discovering all of our resources. This can be done either by using an appliance or also in a very simple way by using a CSV file. So this process is again not very complicated, and we get a lot of help. We can first download a CSV template. That's what we are going to do first. And afterwards, we can open this template and add all of the server inventory into the CSV file. So in here we have opened up this file, and there we can now provide all of the relevant data. We actually only have 4 of these fields that are mandatory. And then we can also add some additional data that helps with the analysis, and therefore we should of course provide as much information as we can to get the most accurate analysis. After we have done this, we can of course then just go ahead and import this file again. So I can just select the file, and then this will be imported, and afterwards it will be analyzed and assessed, which will just take a little while, and after that we can have a look at the results. So if we go back, we see that this is of course usually the first step, and afterwards everything can be analyzed and assessed. Afterwards, we have also in here all of the discovered items, which of course this takes a while until this appears in here. This is for the servers, databases, and web applications. The same process we could also do by just focusing on the databases only. For example, if we don't have any web applications or any other servers. And then aside to all of these resources, we have, for example, also virtual desktop infrastructure, we have web applications, but then also there is, of course, also data that needs to be transferred oftentimes from on-premise into the cloud. And now one way to do this is using Databox. And what that is, we want to discuss in the next lecture. One step in most migrations is also to get the data in and sometimes also out of Azure. And this is sometimes a little bit of a tricky procedure, and therefore we have the solution of the data box. The data box is just a physical device that's used to transfer large amounts of data in and out of Azure. The problem with uploading the data just via internet is that if we have terabytes or petabytes of data, this can be, in the case of a limited network connectivity, very time consuming. Sometimes this can take up to multiple days, and this is not a very reliable and not a very fast way of doing this. The alternative to this in such situations would be to just order this data box, which is just a physical device that can be ordered via the Azure portal. We can just find this in the service Azure Migrate, where we can just fill out all of the required information, such as the shipping address, and then this will be all checked. And if this is possible in our situation, this will be then shipped to us via a regional carrier, and then this will be uploaded automatically in the Azure Data Center. This is, of course, a very fast way compared to uploading the data via the internet if we have terabytes or petabytes of data and we have maybe a limited network connectivity. And this is very inexpensive, reliable, and of course also very secure. Those devices come with a special case and are also password protected. In general, this can be used for both importing and exporting. So getting data into Azure and also out of the cloud, we can use that in both situations. In general, of course, we talk about large amounts of data and usually also in combination with no to limited network connectivity. Otherwise, it would be just faster to upload the data via the internet. And these situations can be, for example, a one-time migration. But also sometimes this can be split up into an initial bulk transfer and then also maybe, for example, every month, an incremental data transfer as well. The workflow for this is very simple. As mentioned, we just in the first step order this data box, provide all of the relevant information, and then we receive this device. As mentioned, of course, this comes in a special case, and also all of the cables that are needed for connectivity will be also included so that we can just copy our data locally in a very, very high speed. And then afterwards, we can just ship this back to Azure, and then this upload process will start automatically. And afterwards, of course, all of the data will be erased according to the national policies. And the process for exporting the data from Azure to our local data center, sometimes this is also necessary, is very similar. Apart from the fact that we don't receive an empty device, but we receive the device with all of our data already on it. And then afterwards, we can copy the data to our data center and then again just return these devices. This is the Azure Data Box that is just a physical device that provides a fast and very reliable and secure way to transfer large amounts of data in and out of Azure. Sometimes we would like to have access to additional, more custom applications, and for this purpose we can access the Azure Marketplace. In here there are some trusted third-party companies that offer their own additional applications and services. And this marketplace can be accessed right from within the Azure portal, so we can search and find these different solutions and also use them from within our Azure account. These companies that offer these services have to go through some certification process where some requirements have to be met, but of course we still should be careful when accessing additional services from these third-party companies. To access this marketplace, we can again either just, for example, search for marketplace, or even if we create a resource, we can see the marketplace from here. And now we can just, for example, filter. We can search for some solution. So for example, I can search for Ubuntu or some other services, and I can also use this category navigation. For example, I want to have some solutions that are related to analytics, and in here I find then these different solutions, and some of them are provided by Microsoft, and of course others are then from other companies. If we want to get access to these services, we can just create resources from within here. We can see what are the available plans and what are some of the ratings and reviews. So this is a very convenient way to get access to additional custom applications from third-party companies. Congratulations on completing this entire module, which was a huge one, and therefore we now just quickly want to summarize and repeat again what we have learned so far. In the beginning, we have learned about the storage account, which is the main cloud solution to store data. In this account, we have different other services that we have learned about later on. For example, file shares, blob storage, queue storage, and also the Azure Tables. Afterwards, we have talked about the redundancy options that are related to our storage account. This is very important to know how they work and in which situations they will protect us. These are in general just how the data is replicated. For example, if we have a locally redundant storage, this means that we have 3 copies in our data center, and this protects against a failure within the data center. This is not protecting us from an entire data center going down or something that affects even the entire availability zone or even the entire region. So it's important to understand what are these replication methods, how they work, and also what they protect against. Additionally, we have talked about the different access tiers. This is also one factor that is affecting the cost of our storage in our blob storages. We have the different access tiers: hot, cool, and archive. To control the cost of our storage, it is important to set these access tiers in the right way. So how the data will be used. For example, if we have some data that's on a website that is just accessed very, very frequently, it is the best for availability and also for the price to choose the hot access tier, even though the storage itself is a bit more expensive, but we have just a cheaper read and write operations for this kind of access tier. Then we have also cool, which is just for example, some short-term backup and just some more infrequently accessed data. And the last one, which is a bit more specific, because this is mainly just for long-term backups and data archiving, because it's cheaper in the storage itself. But when we want to access the data, we first need to rehydrate it before we can access it. So it's a bit more complicated. And also, if we want to access the data, it will be more expensive in that case. So in general, it's important to understand what are the use cases and what are the factors to choose the right access tiers. Then we have talked about the different storage services. For example, the Blob Storage is the main solution to store massive amounts of unstructured data. These can be images, documents like JSON files, backups, videos, all kinds of files. Then we have the Queue Storage, which is just there to store large numbers of messages. Some applications produce messages and then they can be queued until they are processed by other applications when they are then again dequeued. So some queue storage for large number of messages. Then we've talked about the Azure Files, which is a managed file share in the cloud, and the beauty of this is that this can be mounted by on-premise devices or some, for example, virtual machines. And then it can be accessed by different devices, by different users, and basically this is a replacement or supplement of the traditional on-premise file servers. Sometimes it can be very useful in these cases to sync the data from maybe some different locations on premise to our Azure Files. And the solution for this is to use Azure Sync. Lastly, as the last service, we've talked about the Azure Tables, which is just a somewhat basic NoSQL database service. So this can be a good solution if we have some very basic data, we don't need to make any joins, and we want to use a very inexpensive storage for this type of structured data. An alternative to this could be the Cosmos DB, which is also a NoSQL database service, which is a little bit more sophisticated and also a little bit more expensive. Afterwards, we have also talked about the disk storage, which is the storage that is used for virtual machines. We have learned that when we want to, for example, save costs, we can stop the virtual machines, so we don't need to pay for compute, but the storage will still be available and we still have to pay for this. And for this disk storage, we use containers, so it's Blob Storage, which makes sense because we want to store different types of data in an inexpensive way. Then we've talked about AZ copy. If we want to move data from maybe one account to another account, we can use AZ copy, which is a direct and convenient way to do this. This tool is a command line tool. We can either download it to our Windows or Linux machine, or we can also access it from within the Azure portal by using the Azure Cloud Shell. Another tool that we can download is the Storage Explorer, which is just again a convenient tool to manage our storage resources from desktop. In the end, we've also talked about Azure Migrate, which is a centralized platform that offers some tools that are all geared towards providing us a guided and helpful experience for planning our migrations. In a migration, we also need to deal with data transfer, and if the amount of data is really huge and we maybe also have limited network connectivity, we can use the Azure Data Box, which is just a physical device that will be shipped to the data center to transfer large amounts of data in and out of Azure. And lastly, we've also talked about the Azure Marketplace, where we can find trusted third-party companies that offer their own applications that we can access from this Azure Marketplace. These were all of the topics that we've discussed. Again, congratulations on completing this large module. And now in the next one, we are going to dive into all of the things we need to know about identity management, access, and security. That's what we are doing in the next section.